One of the things you would have learnt about in the reading and videos you've been watching so far is that acid rain has harmful environmental effects. So what you're required to do for your course is to be able to describe what those effects are. What this video is going to do is highlight some of the important equations that you can use to help your description of the effects that acid rain can have on the environment. Now, a lot of these reactions that occur in the environment are just examples of general reactions of acids. So the first type of general reactions of acids that we're going to have a look at is the type of reactions that acids undergo with metals. So you should recall that an acid will react with an active metal to produce a metal ion and hydrogen. An example of this is when acid rain comes into structures made out of metal, for example, bridges or towers. So they might be made out of things such as steel, which contain iron. So we'll have a look at what happens when iron comes into contact with an acid. So what you'll notice is we've got our hydrogen ions from our metal. We've got two of those because we need two to form our hydrogen gas molecule over here. It's reacting with the solid metal, in this case iron, which is converted into the metallic cation over here. Something you might want to keep in mind here is that this is an ionic equation. So this cation would actually form a salt with the anion part of the acid over here. Another example you should be familiar with is how acids can react with galvanized iron. So galvanized iron is iron which has a coating of zinc oxide. So the acid would be reacting with the zinc oxide coat. So what you can see here, we've got the zinc oxide reacting with the hydrogen ions, and hopefully you recall from our earlier discussion about acidic and basic oxides that this is going to be an example of zinc oxide behaving as a basic oxide because it's reacting with an acid. So because of that, that means our basic oxide and our acid is always going to react to give us the metal cation and water. So in this case, we're going to get a zinc cation and water. Now, the next step of that is just to make sure everything's balanced, and we can see that because we've got two hydrogens in the water molecule on the right, we're going to need two hydrogen ions on the left there. So just to recap that, example of where acid rain may be affecting metals is in structures such as bridges and towers, or really any structure that is made from metal. Other structures that can be affected by acids and therefore acid rain are structures which contain carbonates. So this is generally our stone structure, which are often made out of substances such as limestone, marble, or sandstone. So this could be buildings or statues or monuments, etc. So limestone and marble are both composed of calcium carbonate. So what we actually have here is a reaction between an acid and a carbonate, which you should recall is always going to give us a salt, water, and carbon dioxide. What you'll note here is this is an example of an ionic equation. So I've just included the cations from the acid and not the anion. So the salt in this case would form from the calcium cation and the anion component of whichever acid we have present. Now, while sandstone is primarily composed of quartz, the quartz grains are held together quite often by either calcium carbonate or iron oxide. So if you've got calcium carbonate present in the sandstone, it is going to react, it's going to be exactly the same as this reaction here. So you're going to have your acid reacting with the calcium carbonate. So what you should hopefully recognise again here is we have got an oxide that is reacting with an acid. So this is another example of a reaction of a basic oxide. So it'll be exactly the same as every situation where we've got a basic oxide reacting with an acid, and that is where we end up with the metal cation and water. Then it's simply a case of balancing the equation. So we can see we've got 2 ions on the left, so we need 2 on the right. Next we can see we've got 3 oxygens, so that's going to mean we need 3 water molecules, leaving us with 6 hydrogen ions that we need on the left. So just to recap, what we've looked at so far are 2 general reactions that acids have with different substances, both metals and carbonates. And when we've got acid rain, the rain can then come into contact with these structures, with these materials in the environment. The other example that we've had a look at is when our acids come into contact with our metal oxides in the environment, and this is just an example of the reaction between a basic oxide and an acid. The other situation that you need to be able to describe is how acid rain can cause the mobilization of toxic cations in soils. There aren't specific equations that you need to know for this to help aid that description at this point. So in your reading, you would have learnt about the situation in which cations are mobilized, but the actual chemical process that occurs, you don't need to worry about too much right now, but you will learn more about that later in the year when we study cation exchange. So when we get to that point, it's important that you make a connection back to acid rain. Okay, so you should be able to write equations for the reactions of acids with metals and carbonates, with oxides such as zinc or iron oxide, and you need to be aware of what it means for cations to be mobilized and also what are referred to as toxic cations. So this is covered in your reading. The actual chemical process here is cation exchange, and you'll learn about that later in the